Let's start our CCNA 200-301 series with TCP/IP model. This model serves as a foundation for all networking technologies that we will explore in the later videos to build a solid knowledge for the exam. In this video, we'll talk about the following topics. First of all, let's answer the question why we need TCP/IP model. Next, we'll find out what TCP/IP model provides in terms of transferring data. Then, we'll see how TCP/IP model looks like. After that, we'll look into where the TCP/IP model exists. Finally, we'll sum up our video with the keynotes. As you can imagine, back in the old days, before having TCP/IP model, many big corporations have already devised their own protocols to allow the communication between their own networking devices. As you can see in Model 1, Cisco has their own proprietary protocols to transfer data between their devices. Similarly, IBM has their own proprietary protocols, and they have no issues when sending or receiving data between their devices. However, when a Cisco device and an IBM device send packets to each other, the packets get dropped. In other words, the communication is impossible among different networking vendors. This limitation created a need for standard models with common set of protocols that can be used by all the vendors to allow the communication among networking devices and operating systems from multiple vendors, like in Model 2. By 1980s, there was two popular standard models, TCP/IP and OSI models. However, only TCP/IP model succeeded and dominates entire market today. We will look into the latest TCP/IP model in this video. Let's look into what TCP/IP model provides. First of all, it is important to note that TCP/IP is a logical model. It is not a physical model, which means you cannot find any physical objects that are considered TCP/IP model. TCP/IP model was created to provide a set of standard guidelines for transferring data among computers with different operating systems over a network that consists of multiple networking vendors. If you look into it deeply, you will see the TCP/IP model expands from a source computer to a destination computer where the data will be transferred across. In other words, it concerns every single object that leads the data from a source to a destination computer. TCP/IP model provides services to convert data from any applications with any formats into standard formats using standard protocols to make it possible for transferring the data between any operating systems and any networking devices. The latest TCP/IP model has 5 abstraction layers: application layer, transport layer, network layer, data link layer, and physical layer. The main reason TCP/IP model takes a layer approach is that it prevents change in one layer from affecting other layers, so that if an issue happens at one layer, it only requires the data at that layer to be retransmitted. When learning about TCP/IP model, I kept asking the question, where is it? However, I could not find it anywhere. I only stopped asking that question when I understood it is a logical model that concerns every single object that transfer data from a source to a destination computer. Therefore, TCP/IP model is implemented on any operating system of any computers and network devices to convert data from any applications with any formats into standard formats using standard protocols to transfer the data to any node in a network. As a network engineer, you should see TCP/IP model encompasses entire network, not an individual device. Let's sum up our video with the keynotes. TCP/IP model provides a set of standard guidelines for transferring data among computers with different operating systems over a network that consists of multiple networking vendors. TCP/IP is a logical model that encompasses every single object that transfers data from a source to a destination computer. The latest TCP/IP model has 5 abstraction layers: application layer, transport layer, network layer, data link layer, and physical layer. The layer approach is to prevent changes in one layer from affecting other layers, so that if an issue happens at one layer, it only requires the data at that layer to be retransmitted. This is the end of this video. Thank you very much for watching.